Okay, continuing on, let's look at some more examples of counting techniques. So from a list of 12 questions, a student is to select 10 questions to answer. How many different sets of 10 questions are there? All right, now the order of the questions does not matter. We're just selecting 10 questions from a larger set of 12 questions, so it's a combination or a subset of questions. And so the answer is 12, choose 10, right? And that turns out to be 66. So there are 66 different ways of choosing 10 questions from the larger collection of 12 questions. And this just shows how to calculate this, again, on the TI-84, as well as on the TI-36X Pro. It would look very similar to this, right? Casio calculators can do this, I'm sure. It might look a little bit different on the calculator. It just depends on the calculator. So make sure that you know how to do these kind of calculations on your calculator. All right, thinking about Mardi Gras, suppose that a crew has 10 members. Each year, a crew forms a committee of 3 people to plan its Mardi Gras float. How many different committees can be formed? In addition, each year the crew elects a group of officers consisting of a president, a vice president, and a treasurer. How many different slates of candidates can be formed from the 10 members? All right, so let's look at this. So suppose that a crew has 10 members. Each year a crew forms a committee of 3 people to plan its Mardi Gras float. How many different committees can be formed? Well, in this problem, in this question, there's no indication that order matters. There are no, in this particular question, the members don't have positions, right? It's just a group of 3 people. They're going to get together and they're going to plan the Mardi Gras float. That's what they're doing, right? They're planning. So there's really no, the order that they're selected or the order that they're put on the committee does not matter. All right, so order doesn't matter, so the number of ways that we can select 3 people from this larger group of 10 people, all right, in order to plan the Mardi Gras float is 10 choose 3 or 120. So there are 120 different ways of forming such a committee. And this just shows the calculation on the TI-84. Now, in addition, each year the crew elects a group of officers consisting of a president, a vice president, and a treasurer. And so how many different slates of candidates can be formed? Now, in this problem, order does matter because the people hold different positions, right, in terms of the offices. And so we're not looking at combinations here, we're looking at permutations. Right? This is an arrangement of 3 people taken from a larger group of 10 people, and the arrangement would correspond to the different positions, the president, vice president, and treasurer. And so the answer to that is 10 permute 3, which turns out to be 720. So there are 720 slates of candidates that can be formed, or 3 candidates that can be formed from this membership of 10 people. All right, the next example says that a committee of 6 people will be formed from a group of 17 people, of which 10 are men and 7 are women. Now, how many committees of 6 people can be formed? And then how many committees of 6 people can be formed if there must be the same number of men and women on the committee? All right, so let's... Oh, and then some additional questions. How many committees of 6 people can be formed consisting entirely of men? And then finally, how many committees of 6 people can be formed consisting only of women? All right, so let's look at these. So a committee of 6 people will be formed from a group of 17 people, of which 10 are men and 7 are women. How many committees of 6 people can be formed? There are no constraints here. You can have any possible combination of men and women on the committee. And so there's only one step here, which is to select 6 people for the committee. And order does not matter here. There's nothing that says that the committee members have different positions. And so we're looking at a combination or a subset of 6 people taken from the larger set of 17 people. So the number of ways of doing that is 17 choose 6. All right? And that turns out to be 12,376. So the number of ways of forming a committee of 6 people from the larger group of 17 people is 12,376. Now, how many committees of 6 people can be formed if there must be the same number of men and women on the committee? So we're going to have a committee of 6 people. We've got to have the same number of men and women on the committee, so there have got to be 3 men and 3 women. And so we can think about the process or procedure of constructing such a committee. We can break this down into a 2-step process. Select 3 men for the committee, and then select 3 women for the committee. Now, the number of ways of selecting 3 men for the committee is going to be 10 choose 3 because there are 10 men to choose from, and we're only going to select 3 of them. Right? And that turns out to be 120. Step 2, select 3 women for the committee, can be done in 7 choose 3 ways because there are 7 women to choose from, and we're selecting 3. And again, order does not matter. And that turns out to be 35. Okay, so this shows the 120. This shows the 35. And so then by the fundamental rule of counting, there are 4,200 possible committees of 6 people with an equal number of men and women on the committee. How many committees of 6 people can be formed consisting entirely of men? Well, again, we can think of this as a 2-step process. Select the men on the committee and then select the women. Well, there are going to be 6 men on the committee. The number of ways of doing selecting 6 men for the committee is 10 choose 6, which is 210. And then once we've selected the men, step 2 is select the women. In particular, we've got a little typo here. Select 0 women for the committee. So that's step 2. That can be done in 7 choose 0 ways. Well, there's only one way to do that, and that's to not choose any women. Right? So there's only one way to do that. And so then by the fundamental rule of counting, there are 210 committees of 6 people that consist only of men. So not that many. How many committees of 6 people can be formed consisting only of women? Well, again, we can think of this as a 2-step process. Step 1 in this case would be to select 0 men for the committee. That can be done in 10 choose 0 or 1 way. Step 2 would be select 6 women for the committee. That can be done in 7 choose 6 ways, and that turns out to be 7. And so by the fundamental rule of counting, there are 7 possible committees of 6 people consisting entirely or only of women. And so continuing that previous example, suppose that the committee is formed by randomly selecting names out of a hat. All right? And when we say that, what we mean is that all possible committees of 6 people are equally likely. And so with that, assumption here, what is the probability of selecting a committee that has an equal number of men and women? What is the probability of selecting a committee of 6 people that has all men? And what is the probability of selecting a 6-person committee that has all women? Well, we've got all the ingredients we need to calculate this. Because the names are drawn randomly, well, let's see, what are we doing here? What is the probability that the selected committee of 6 people consists of an equal number of men and women? So 3 men, 3 women. Because the names are randomly selected from a hat, all possible samples are equally likely. And therefore, the probability is given by the number of ways of selecting a committee that has equal representation, 3 men and 3 women. We found that to be 4,200. Divided by the total number of committees of size 6, which is 12,376. And so this probability is fairly high, 0.3394. So there's about a 33 or 34% chance that by selecting the committee at random, we're going to get equal representation of men and women, 3 men and 3 women. Now, what is the probability that the selected committee of 6 people consists of all men? All right, so 6 men and 0 women. Again, because the names are drawn randomly, all possible samples are equally likely. And so the probability is given by the number of ways that we could select the committee of size 6 with only men, divided by the total number of ways that we can select the committee of size 6. And so 210 over 12,376. And so that probability is only about 2%, 0.017. So the likelihood, if we select the committee at random in the way that we've described, by pulling names out of the hat, there's a very, very low chance that we would select a committee that has all men. What is the probability that the selected committee of 6 people consists of all women? Well, again, because the names are drawn randomly out of the hat, all possible samples are equally likely, and so the way to calculate this probability is to calculate the number of ways, or to calculate the ratio of the number of ways that we could get such a committee divided by the total number of possible committees. So 7 over 12,376. And that probability is even smaller, 0.000566. All right, one more example. An urn contains 12 poker chips numbered 1 through 12. Now, a sample of 6 chips is to be selected at random and without replacement from the urn. So the first question is, how many possible samples are there? And then the second question is, what is the probability that the selected sample contains the chips numbered 1 through 6? Okay, so how many possible samples are there? Well, again, we're selecting a sample at random, at random and without replacement. So we're selecting a subset of 6 chips from the larger set of 12 chips. Order does not matter, right? And so the number of ways of doing that is 12 choose 6. And that turns out to be 924. Now, what is the probability that the selected sample contains the chips numbered 1 through 6? Well, because the samples are equally likely, okay, because we're selecting at random, what that means is that, or what that implies, is that all possible samples, all of these 924 samples are equally likely. Right? And so the probability that we're looking for here is going to be equal to the number of ways that this event can occur divided by the total number of ways divided by the total number of possible samples. Now, there's only one way for the sample that we've selected, the sample of chips that we've selected, to have the numbers 1 through 6. That's the only way that can happen. So there's one way to do that. And so this probability that we're after, the probability of selecting the chips numbered or labeled 1 through 6 out of that urn, that probability is 1 out of 924, which is 0.00101. Okay, so that wraps up the examples on counting techniques. These are very, very useful. Make sure that you can do these various examples. Go back through and calculate, do the calculations yourself. All right, so I'm going to stop the video here and we'll pick up with the next topic in the next lecture video.